an amazing line of talks with industry leaders on interoperability and AI. That will definitely benefit you. So stay tuned for that. Also, follow us on all our social media channels. Just in case if you're wondering why we are doing a healthcare industry based meetup, it's because we have been working closely with the healthcare industry for a very long time, and we have gained so much from them that we want to share it with you. We want to just share those things with you. So, to tell you more about where we are and why we are doing this with the healthcare industry and the community, I would like to introduce our keynote speaker for the day, Pramada Sahu. She's she's our Chief Portfolio Officer, and she'll be giving us an insight into how Geeky Ants is shaping itself for the healthcare industry. Hi, Pramada. How are you today?
Hey Sana. Yes, I'm doing absolutely fine. You also look quite smiling, refreshing.
Yeah. So yeah, let's just take start with our talk. Go ahead.
Sure.
The stage is yours, Pramada.
Thank you. Okay. Uh, yes. I hope my screen is shared. Let me just get started. Cool. Hello, everyone. Thank you for being here today at the Geeky Ants meetup on interoperability in healthcare. My special thanks to our audience and speakers who have joined us from outside India, especially from London and Florida. Thank you very, very much. Uh, I'm honored to have become your keynote speaker for this evening today. A very, very warm welcome to each one of you who have joined us today for this healthcare meetup. I am Pramada and I lead digital healthcare program and business growth at Geeky Ants. Before we delve more into interoperability and its exciting world about interoperability, let me share a brief story with you. One of my uncles became unconscious a few months back. We had actually immediately rushed and admitted him to the emergency department. Fortunately, he was wearing an Apple Watch, and his healthcare provider could actually transfer his ECG reports to his medical device, and we could find that an hour back he had a cardiac arrest. Without any further delay, he had to actually undergo a heart surgery. That is where interoperability helps. We could actually save his life with a better data, and also the decision making was quite fast just because the data could be transferred and we could analyze that he had a heart attack some time back. That is the goal of healthcare interoperability. The goal of healthcare interoperability is to connect healthcare systems electronically to facilitate electronic share of data. It actually provides a common language to communicate. For today's meetup, we are mostly going to focus on four important topics, which is around healthcare data exchange architecture, application program interfaces, the policies around this, and also, very importantly, the healthcare standards. Moving on, it is very, very important for us to know why interoperability. Why are we talking about this? And why is it that important? We all remember during COVID-19 pandemic that home-based care were given to the patients. And patients with the chronic disease, it became very inevitable for them to stay at home and get their physiological parameters tested and pass it on. They could actually do this with the help of medical devices. They could transfer their physiological parameters wirelessly to the healthcare providers, and the healthcare providers, by sitting at their home, could actually visualize and take decisions based on the reports that they have received from the patients. That's why it is very important. What does it do? It improves patient safety. It gives more accurate reporting. It gives better access to complete patients' health records. it also reduces errors and improves efficiency. That's why it is very important to understand interoperability in healthcare. Okay, so we are going to, as I explained about interoperability, what is the standards? Okay, so interoperability actually requires standards. Standards give the frameworks to facilitate the secure exchange of data between disparate systems. We have different organizations. It was first started by Health Level 7, which has actually given a set of international exchange standards for sharing data between healthcare providers. Another healthcare standards which actually emerged from HL7 is the FHIR, which is Fast Healthcare Interoperability Resources. Nowadays we're talking about DICOM, which is again similar, but this standard focuses more on images. During this talk, during this entire next 2 hours, we are going to focus more on the standards, and we will have some perspective around how FHIR data is exchanged and transferred in the particular format. Okay, moving on. Why Geeky Ants and what we are doing here today, and how Geeky Ants is taking part onto this. In past, we have actually done a very exciting POCs and engagements with our client, where we have actually stored patient data in FHIR standards, which has enabled patient to access data using secure channel. The secure channel is very important, so we apply some compliances and all that, which our speakers are going to talk about that. Also, another very exciting work that we did is the automating the process of transferring patient data from one payer to another if a patient wishes to change his payer, which is the insurer. Also, we have integrated with the platform which expose data in HL7 formats to send any new activity notifications about patients. With this, actually, data decision making has become very easy for the healthcare providers if they get if there is any change in the patient data. This one we have done already. Apart from this HL7 and FHIR standards, we have done in healthcare major projects with our clients, and which has been actually going on. We have worked on the teleconsultation applications. We have built customized solutions for our clients where they have been using our modules to work with the patients and book their appointments. We have worked on patient portals. We are actually working on a data decision platform. Another very important POC which we are working on is AI driven medical coding, and AI in healthcare is something very important, which our speaker today is going to talk about that. So, moving on, let's not waste our time. I would like to quickly introduce all our speakers for today who has given their valuable time to join us today. My special thanks to, so we have Dr. Anuj. Thank you so much, Dr. Anuj, for joining us from Medanta Medicity. He is going to talk about interoperability in diagnostic labs. We have Ruben, who is going to talk more about FHIR interoperability, mostly on the US perspective and compliance. Our expert Abhishek Anand, he is going to talk about export FHIR and convert FHIR. I just love his presentation. And a special warm welcome to Ravi sir. He is a Palm Power CEO and founder. He will talk about interoperability in healthcare. We have Kapil from Adobe. He will talk about 10 benefits of artificial intelligence. We are quite excited to have our thought leaders for today on this meetup. Thank you so much. Over to you, Sana. Let's get started.
Yes, I think thank you for that, for this amazing keynote talk. Thank you, Pramada. We'll get started with the event. I would like to introduce our first speaker for the day, Ravichandran, who is a founder and CEO of Palm Power. He's passionate product development specialist with 30 years of experience in technology and in health tech. He's also a technology advisor in a very charitable cancer hospital located in Assam. So he's here with us today to talk about interoperability in healthcare. Hello, hi Ravichandran. How are you
Hi,
today?
I'm good. How are you all doing?
All good, all good. We're all
Oh,
good.
good. Yeah, okay. Thank you very much for the introduction.
All right. I think we can get kickstart with the day. Over.
Okay. Good evening, everybody. Are you all able to see my presentation?
Yes, we can see your screen.
Okay, you are. Okay. So, thank you very much, Geeky Ants, for giving us this nice opportunity to share our experiences in healthcare and specifically when it comes to interoperability. We are basically a practice management solution company. We have a product around practice management, and we also have an EMR component inside the practice management that are being used by hospitals as well. And we have a patient health record application as well. And built into all this is a teleconsultation module. Okay. Now, when we worked on these projects and these modules for the past 6 years or so, we have come across many use cases of why systems have to be interoperable, especially when it comes to larger hospitals and entities that are larger than clinics. Okay, but there are use cases that are specifically for clinics as well, which we will touch upon. So today's presentation is going to be more overview of what is interoperability and what are the issues without interoperability, what are the issues, what are the benefits of using interoperability, and how do you achieve interoperability, what are the standards. Okay, and a glimpse of how these standards look, and also a few use cases of how we used interoperability in some of the situations that we encountered in our recent past. Okay. Um, so if you post this, I've kept a little bit of time for any questions and answers. We can address any specific questions about what we talked about today. Anything out of the scope, you can always reach me. You can look at our company's info at www.palmpower.in, and my mail ID is ravi@palmpower.in. You can also send me a mail if at all you have some questions about what we talked about today or even otherwise. So the official definition of what interoperability is the ability of a computer systems and software to exchange and make use of information, right? So here we are talking about computer systems, we are all talking about software, we are talking about exchange of information, and we are also talking about making use of this information in a meaningful manner. Okay, these are the main components of why we need interoperability. Okay. So problems that you will face if you do not have interoperability are these. Okay. So it all started with unwillingness to share information, right? So software companies that have been early in the market with respect to healthcare, these are like larger corporations. Okay, they got on to the opportunity much earlier. When it comes to EMR and healthcare software systems, probably we are like 30 to 40 years behind the leader, which is the United States. Okay, but there's a good side to it, okay, because we can always learn from them and leapfrog in terms of technology, which is what we have done in the other segments like finance and telecom as well. Okay, so we jumped right to 3G and 4G, skipping the CDMAs and 2G revolution that happened in the United States. Similarly, here in healthcare, there is something that's happening which we will touch upon briefly, but there are other people talking about it, so I wouldn't take much time about ABDM, which is what is happening in India. Okay. Then the second issue that we have is corporate wanting to monopolize information. Okay. When the corporates hold the patient information, okay, now they indirectly hold the customers to themselves. It is not a bad thing, but the problem is that if the customer wants to switch their provider, so it becomes very difficult. So when there is interoperability, switching over is easy and sharing is easy. And when it comes with the government mandate, it becomes much more easier to share information, and it becomes a law of the land, so that everybody has to share information. Okay, this is what happened in the United States. It has not happened in India yet, but it is likely to happen in the near future. Okay, early on, whoever is innovating, okay, they just innovate based on what they know, what the situation demands. Okay, but as we progress in innovation, at right time there has to be some standard that needs to be set, so that interoperability becomes a norm. Instead of an option to do it, it should become a norm. In many areas we have seen interoperability. For example, if you take UPI in India, the government has created the National Payment Corporation, and everybody had to adopt to a particular set of APIs that the government set. And now you have many UPI applications that stick to that standard, and people can switch from Google Pay to Phone Pay to anybody else. Okay, without any worry at all. Okay, so in healthcare, it has still not happened. It has not become that seamless yet, but then it will happen. So there are efforts that are going on by the government. Government also has come up with an infrastructure. It has come up with an API, and there is no strict mandate as yet. It is optional today, but then it will definitely happen down the road. Okay. So when you have interoperability, okay, then cost of migration and adoption, okay, will become easy. But without it, it becomes very difficult. You are stuck with one provider of software. You're stuck with a set of a set of non-standard applications. Okay, so moving away from any of this kind of software is going to become difficult, and it will also become very expensive. Okay. So early adopters would have created legacy systems. Now, if you have a standard, at least you can write a small plug and play module which will adopt the standard on one side. On the other side, it will give interface to the legacy systems as well. So having a standard always gives a benefit. Okay. And having standards is the key foundation for interoperability. So as I told you, the advantages of having interoperability is the freedom of choice. Okay, I can choose any vendor, and if I don't like, I can switch over. So this is the main criteria for any of the large corporations to adopt a standard-based, software, technology or software. Okay. Freedom to switch and freedom to choose. Okay, these two are, you know, once you choose, okay, you should also have ability to switch. Okay, so having an interoperable system gives you both. Okay. And it also gives you much cost advantage in terms of running costs, because if you adopt to a standard, you can plug and play easily different systems. For example, in a hospital information system, you can have a billing system from one vendor, you can have an EMR from another vendor, and you can also have inventory and lab and pharmacy. They will all have their own systems, and it will also give you a real good feature benefits as well as cost advantages. And also having standards and interoperability give you ability to analyze the data electronically. Okay, without that, each one of them will be having their own masters. Each one of them will be having their own codes, and it become a nightmare to make meaning out of any of this data. So interoperability gives you these big advantages. So in the healthcare, when we were implementing our application in clinics and hospitals, we have come up with these kind of scenarios that demand interoperability. Okay, a doctor wanting to share information with another doctor or another facility. Okay, that is within the facility they want to share. Okay. A doctor wants to share across facilities. For example, a hospital like Medanta or Aster or Apollo, they are all having multiple centers. Some of the centers are specialized centers. So from one specialized center, you want to move a patient to another specialized center. Okay, how can you move the patient's information? Okay, seamlessly. Okay, this is another scenario that we have encountered recently. An intra-facility, for example, you know, Aster Hyderabad wants to share information with Aster Cochin. Okay, and some of the cases, what has happened is that when you are talking about the same organization, let's say Aster, but they are having two different centers, the same software provider has given the software, but they are of different versions. Okay, so it becomes difficult to exchange information in such scenarios. But we have overcome these limitations. But I'll tell you architecturally how we have overcome this situation. Now, interfacility using the same software with different versions from the same vendor is what I explained to you just now. The other scenario is interfacility using different software vendors. The doctor wanting to share information with patient, doctor wants to share information with other providers. For example, the doctor has written a prescription and he wants to share it with a lab or he wants to share it with another, let's say a pharmacy. Okay. Patients wants to carry their information so that when they are traveling abroad, okay, if there is a standard, if they are carrying their information, then it becomes easy whenever there's an encounter. And patient also today wanting to share information with other providers like pharmacies. For example, if they want to buy something, okay, how can I share the prescription written by a doctor to the pharmacy? Okay, so these are the broad use cases that we have come across when we are implementing systems. Okay, now when it comes to standards, okay, so there are different classes, okay, of what the standards comprise of. One is the big messaging standard. How do I communicate with another system? So there are protocols developed, in HL7 messaging. Okay, so you have things like, okay, how do you handshake? How do you exchange information about your capability? And how do you send heartbeats so that two different systems know that the other systems are working. Okay, so these are messaging standards. Then we have data formats, a standardized way of exchanging information. And then there are nomenclatures like a parlance, and then a syntactical way of expressing certain information. For example, how do you say that the patient is having cold, or how do you say a patient is having a knee joint pain on the right hand side on the right knee? Okay, these are a standard parlance and a specific way of communicating both electronically as well as verbally, okay, among practitioners and providers. So the predominant standards in healthcare are the following. Okay, we have HL7, which also has a communication piece of it, and it also has a data format. So if you look at the slide, HL7 started in 1987, way back, and they have come a long way, and it is still predominantly used between machine-to-machine communication, because there are so many machines that came into the market, probably 10 years ago, 20 years ago, even prior to FHIR, they still use HL7 communication data formats, and they're not going to go away anytime soon. But then we also have FHIR, okay, which is the Fast Health Interoperability Resources, which is much more readable, much more structured, easy to modify, easy to add. Uh, Basically, these resources are JSON structures, and you can also have XML structures for FHIR, but then what I have seen is predominantly JSON is being used. We also have the clinical document architecture, which is predominantly used for doctor to patient and patient to doctor exchanges. So there are applications that creates CDA documents, put it on let's say a removable drive or a pen drive, and you can carry it and then use it whenever is necessary when you're traveling, right? Then we have SNOMED CT. Okay, this is predominantly used for basically providing a clinical terminology. How do you say that the patient is having fever with chills? How do you say the patient is having, glaucoma on the left eye? When these are, standard-based clinical documentation. Then we have LONC, which represents, this is a standard to represent your lab results, and the lab values, like how do you say what is the CBC count? Okay, how do you say an MRI terminology? I mean, these are um, clinical terms for lab results. Then we have ICD, which is basically a disease code. Okay, from ICD 10, the world is slowly moving to ICD 11, but they are also making these two interoperable. These are basically disease code, which are basically diagnosis codes and also procedure codes. Okay. Then we have NCPDP for exchanging prescription drugs, and finally we have DICOM for imaging standards. So this is how an HL7 data looks like. Okay, it's very cryptic. Making meaning out of it just by looking at it is going to be difficult. You need to really understand this format to make sense out of what it is. But then it's been predominant, and it is currently even currently used in machine to machine exchanges predominantly. Compared to HL7, this is how the FHIR data looks. Okay, and what I've represented here is in JSON format. But as you see it, okay, you can make some sense out of it, right? So that is the biggest advantage. But it looks a little, verbose and heavy. But then if you use compression, this can get really compressed to a very small size for information exchange. So the size will not be a problem, but I'll show you an example. It really looks very verbose, but when you use compression, this may not really be a problem. Okay, but then the advantage is when you look at it, you know what it is. So the SNOMED CT advantage is that it's a very structured information. So there are concepts and there are hierarchies. It starts from body structure, going all the way to what are the specimens, what are the scales, and it is a completely structured information. And they also provide relationships. They also provide attributes. Okay. For example, like whatever is given here, if it's an arthritis is also an orthopathy of a knee joint, which is also a higher classification of arthropathy. And then we have, it's nothing but a finding of a joint, okay, on your leg joint. When you say leg joint, it is also part of a musculoskeletal system. And on the top, it says that it's a finding by a body structure or a body site. Okay, so then there are many relationships that you can build over this SNOMED CT database. So you should be able to find things like, okay, give me all the problems that are associated with that is arthritis, okay, or give me all the issues that are related to a knee joint. Okay, so these are relationships that are built over SNOMED CT database, and you should be able to query it and get relevant information as and when needed. It's a pretty structured information, but it is also complex to understand. Okay, so the complexity needs to be reduced to a great extent by the software providers to make it easy for the doctors to adopt it. Okay, and that is one of the things that we do in Pramada. So ICD-10 codes, okay, looks like this. Okay, there are classes of codes. Okay, when you say, C00 to D49, they all represent neoplasms. And then when you say E13, okay, it relates to diabetes and it's a diabetes mellitus. So these are all classified codes, and these classifications are predominantly used, for communication between providers and payers. Most of the systems for insurance uses ICD-10 code for processing. Okay. Now coming to architecture, okay, so I have given some three, four architectures here. Two of them are something that we have used in the past, and one of them is this. Okay, so this is a communication infrastructure between two centers, okay, of Aster hospitals. And what happens here is that there are two centers, one on the left hand side, which is the Aster MedCity Hospital, and on the right hand side, which is the Aster Kannur. Okay, the piece in between is our application that provides the interoperability. Okay, and all communications happen over VPN for security purpose. And one doctor sitting in MedCity in Cochin will be able to access information from another doctor who was created for the same patient sitting in Kannur. Okay, and what we have done is we have used a central server that provides communication. The central server is located in Bangalore, whereas these two servers, they are sitting in their respective center, one in MedCity and one in Kannur. Okay. Looks like my 20 minutes is over. I will try to squeeze the other slide as quickly as possible. Can I take 5 more minutes?
Yes, sure. Yes, sure, you can take.
Okay. So here, this use case is where, it is again multiple centers, but then one center is using one provider and another center is using another software provider. But the second center is using a HL7 standard, but the first center is using their own proprietary standards. Okay. So what happens here is, if you really look at the difference between the other two, now there is a center, there is an in-between piece that is sitting here. Okay. So this is an HL7 endpoint provider. This is what we call it as these are all adapters, and the adapter's job is to translate, okay, from one format to another format and vice versa. But then imagine if there are 10 such providers, I'll have to sit and write 10 such adapters. Okay, and obviously we are going to charge the client for it, and obviously there is a acquisition cost for the client. Okay, but then if all of them are HL7, then it becomes a plug and play. Okay, so here, this is another piece that we have written. This is called a health locker. This holds information, who shared information with whom, for how long, okay, and how long it's valid, okay, who can have access rights and stuff like that. Okay, so this is another use case that we predominantly use whenever we go to our clients, and to make them comfortable that even though you have disparate systems, we can make systems communicate with each other. So this is more of a US use case, which is a health information system, which I'm sure Ruben will cover. I will just give a very small overview. So there is this middleware here, and these are the providers, and each provider having their own repository. And then these are the users. Clinic 1 wants to use some data sitting in repository 1. Clinic 2 wants to use some data sitting in repository 2. And the central piece is the one is doing all the translation, like how I showed you the other just before. Whatever I showed is something similar, not exactly the same, but just something similar. Okay. So this is our ABDM. Okay. So we have, I would say that we have leapfrogged here as well in terms of learning from others and adopting something that is better, taking the advantage of the best of everything. Okay. So the centerpiece here is the ABDM gateway. Okay. This is owned by National Health Authority, and this is the one that has provided the standards for us. Okay. But then the underlying data standard is the FHIR data standard. Okay, some minor modifications have been done, but then if you really look at it, okay, there are hospitals here which are using a health locker. One, health lockers are nothing but storage providers, storage of health information providers in a very, very highly secured manner and very, very performant manner. So one set of hospitals and labs and clinics are using one health locker. The other set is using the other health locker. There are health information providers and there are health information users. And the centerpiece is the one that is facilitating communication between these disparate systems, okay, in a standard manner. So if you write your software to ABDM compatible protocols, then you should be able to access information and contribute information of a patient to any one of these repositories, to any one of these providers. Okay. However, you need the patient's consent, which is managed by this consent managers, which is also part of the gateway. Now, the government is also looking at how do we, create uh, more gateways, make it more democratized. Okay, so they are also looking at creating private consent managers, creating private gateways, and how do they interact. Okay, that is still work in progress. So I'm just going to give you a little glimpse about what is FHIR, because there are other people that are going to talk about FHIR in much more detail. Okay, FHIR has got resources, and resources are grouped into resource categories. There are foundation category, there's a base category, there's a clinical, financial, and specialized categories are there. So in foundation, okay, all these are resources inside each of these categories. In base you have further subcategories, and then each category has got a resource. I mean, these are all in open source. You can go to fire.org and hl7.org. You will be able to see all of them. I'm just giving you a glimpse and an introduction to these standards, so that you are at least aware of these standards and aware of the parlance, and you can get much more information by going through the web, and you will be able to put things into context because you have already heard these terms. This is another set. Since I've run out of my time, it is running through pretty quickly. Okay, and this is just an example of how a FHIR resource looks like. Okay, as I told you, the biggest advantage is the ability to make sense just by looking at it. And then the FHIR also gives ability for you to intertwine structures. Okay, one resource can have another structures, and all these resources can be bundled into a bundle for communication. So it's a pretty well organized, and it has come from years and years of experience in the United States. So this, I think, is a good to go protocol. So the key learnings are, these. Interoperability standardizes communication between computer systems, and these are, basically the standards are enablers for interoperability. Okay, so it gives the advantage of freedom of choice, cost of advantage. The cost advantages, ability to digitally process information. That's a big advantage. And we have these standards that are predominantly in play today: HL7 CDA, SNOMED CT, LAW-NC, SNOMED CT for clinical terms, LAW-NC for lab results, ICD for disease codes, FHIR for communication, DICOM for imaging. Okay, so the Indian scene, the Indian Government National Health Authority has implemented a countrywide HIX called ABDM. They have also defined the protocols, and there are many software providers who are currently integrating their systems with the ABDM. So, I've given you a couple of use cases. If any of you are architects, you can take some learnings from the architectural perspective. They are not in detail, but however, it gives you a good overview of what are the things that we are facing in the market today. I'm not sure whether we have time for questions. Um, Sana, can you help me with how do we go about this?
Yes, I do not see any questions on the panel, on the
Okay,
chat box yet, but they are
okay,
actually very much appreciating your talk. They are telling that you are speaking about the real world problems and describing the problem. Thank you for such
okay,
an
great.
insightful talk.
Sure. I look forward to other people, whatever they are saying, I look forward to listening to them. Thank you very much.
Definitely. Thank you so much. Please stay till the
Thank
end
you. Yeah.
for a quick photo. Thank you. All right, so we can move on to our next speaker for the day. Let me introduce you to Dr. Anuj Prakash. He is an experienced and highly trained MD biochemist. He currently holds a position of senior consultant and head of the biochemistry department at Medanta Hospital. He's going to share his knowledge on interoperability in diagnostic labs. So, over to you, Dr. Anuj. How are you today?
Thank you, Sana. I'm doing fine, Sana. Am I visible, audible?
Yes, you're
Okay, great.
visible and audible. Thank you for taking out your time.
Okay. So thank you, Sana, for the nice introduction. And of course, the geeky ants for giving me this opportunity to speak on this topic of interoperability in healthcare. Uh, so I think the keynote address by Pramada has set the stage right, and which get further, I would say, enlightened. We got by Mr. Natarajan's address. He has told in quite detail about interoperability in medical or healthcare. I'm coming from a hospital segment. As you know that I work in a tertiary care center in Gurugram called Vedanta Medicity. And so just before starting my presentation, I would like to give a brief to all the audience. What are the challenges we face as a big hospitals? We know that, or you all must have faced the overcrowdings, the longer waiting periods. Just a matter of fact, ours is a 1,200 bedded hospital, and we cater to approximately 20,000 tests a day in our lab. So we generate a huge amount of data. And when I say we, means the other departments like radiology, nuclear medicine, all these departments are generating like data in millions. And other issue is the ever rising healthcare costs. They say that Indians had spent around $45 billion in 2015, 2016, and which has gone further to around $72 billion by 2020, and which might turn to $100 billion in this year or so. So what can be done? Can we be able to help, or can the technology help in mitigating these issues? Yes, because there is a report by PwC which says that digital health or the interoperability could save 99 billion euros to the EU, $14 billion to Brazil, and $38 billion into Mexico. So you can see that there's a huge scope of mitigating these risks, these costs, or making the whole healthcare process more efficient if we could able to use these tools in the form of interoperability. So this is it's a very apt topic for this era, and I'm sure India would also take a lead in this front. So let's start. So what is interoperability? I think I will not spend too much time on this. That I think our previous speaker has already told us in quite detail. But just to give a brief background, it's a simple word which says that your health, your hospitals, your pharmacies, your patients, your doctors, your labs, your other allied health services are interconnected to a web or a process which is called interoperability in a simpler terms. So I told you the challenges in healthcare delivery systems. So what are the challenges? As I just mentioned, the controlling costs as increasing day by day. There is a lot of consumerisms in the marketplace. The hospital has to provide the services at a very breakneck speed. They have to stay ahead of changes and upgrades in healthcare technologies. We can't stay behind because this is one area where technologies are coming at a breakneck speed. You have to maintain at the same time. It's a highly regulated environment. Healthcare is bound by or governed by a lot of regulations, so you have to maintain those regulatory compliances in place. And so what is the central solution for all of these issues? Interoperability can be used as a central element of all of these issues and can help in mitigating these challenges. This is just a snapshot which says that what is the scale of this issue. They say that this is about 1 in 10 people are over 60 years old. This is, of course, the US data, that it's an aging population, which is in the all developed countries are facing now. They say that by 2050, 1 in 5 people will be over 60 years old. People aged over 60 will outnumber children by 2050. And 38 million of the 56 million global deaths were due to non-communicable diseases. So it's another area where the cancer and the cardiology, which means the heart disease disorders, have taken preponderance over communicable diseases. And there is a shortage of health workers. They say that number will further decrease actually. And so Africa, they say, has 2% of global physician workforce, but 25% of the global disease burden. And this number is even higher in the US, where 86% of the current health spend is on the healthcare. And they say that over the next 20 years, chronic diseases will cost the world around $30 trillion. So you can see that, you just imagine or just see the magnitude of this problem. And so obviously we need to have some solutions. We need to have some solutions which can help us in these areas. So the whole world is working on this segment, and this segment can be addressed, they say, is by one solution, which is like interoperability. Interoperability, they say, is like a translator. It is that person between two different nationalities, people, and can speak their language and help them understand what the other person is speaking from other country. So basically, a mature interoperability position can help the organization or hospitals to address these significant problems. So let us see how does this would help in these problems. So I don't know, definition, we know that it is the capability of two or more systems or components to allow the exchange and use of information across systems. So that's a plain and simple definition. In the healthcare context, I just mentioned that this integration is basically what is happening, which has become very vital as healthcare becomes more digitized and collaborative. And it is aiming to provide accurate and timely diagnosis for improved patient outcomes. Now, so since my topic is diagnostic labs, and I come from a diagnostic labs side, so from that perspective, I would say that interoperability involves connecting the lab information system, that is the LIS software, and other relevant technologies to facilitate the seamless flow of data. So you can see the diagnostic labs or the radiologies would play a big role, because as I mentioned earlier, these departments generate a lot of data. So what are the levels of interoperability in healthcare IT systems and applications? You can use these levels in hospitals, medical centers, many registries like cancer registries, cardiac registries, mental health registries. You can use this application in health tech startups. You can use these registries. You can use these systems in health plans, which is by the government bodies. You can have the online pharmacy platforms on the same systems, and of course the medical laboratories and the radiology departments. So they say there are 4 levels of healthcare interoperability. These levels means they go from a very basic, that is level 1, to the highly desired or the most complex, the level 4. So these are the 4 levels, which say the level 1 is the foundational interoperability, level 2 interoperability, level 3 is semantic interoperability, and fourth is organizational interoperability. So what are these levels? In a simpler terms, the foundational interoperability is which the system requires, which system still requires human assistance to interpret the data they receive. In structural interoperability, data is exchanged between two systems and can only be interpreted at the data field levels. In semantic interoperability, systems are fully capable of interpreting the exchange data. And the best or the last, I would say the highest level is where systems provide top tier interoperability by including non-technical operations like policies, social, legal, and organizational aspects. These 4 levels are given by, as you know, that this is the mainly US has done this research on this area, which is called American Healthcare Information and Management System Society, which is called HIMSS, has defined these 4 levels. So the first level is, so basically it says that different healthcare systems and softwares must be empowered to exchange data with all related provisions executed at the earliest stage of the design and mobile application architecture across local networks and web-based environments. The recipient system should be enabled to intake the medical data from another system without additional technological tools. And it allows for interconnectivity requirements that let every authorized agent send and accept health data in a fast and totally secure manner. Next comes structural level, where you have message formats and other technical provisions, which is necessary for smooth data exchange in inner networks and across the web. And we just have heard we've just heard Mr. Natarajan, where he spoke about a lot of standards. For example, FHIR and HL7 standards. You need to have a specific tech definitions of the way the recipient systems read and interpret the medical data accurately, including syntax of data fields, information structures, and anthologies of patient records. And every tech aspect that is required to keep precise and correct clinical meaning and the value of every data piece transferred between HIPAA-regulated software. Third level is semantic levels, where it is a human-focused rules of data exchange, where it's standardized formal definitions acknowledged by all authorized parties. And then there are the coding vocabularies and data set codifications in healthcare, and a shared understanding of medical data between all potential users. And the last one, or the highest level, is organizational level. It refers to seamless sharing and interpretation of patient data between various organizations with different goals, regulations, and requirements. To achieve this level, you need to have additional considerations such as policies, legal, social, and organizational aspects. So what are the relevance of interoperability in diagnostic labs? If I say the relevance is, first of all, and the foremost, is the efficiency. As I told you before, that we cater to around 20,000 tests a daily, which is actually keep increasing on a daily basis. We are seeing an increase in the load. And how can we be efficient all the time? So there is a big role of interoperability will play. Next is accuracy. You need to have very accurate lab results. You can't, in this era of higher healthcare, we can't afford to make even a single mistake. So accuracy can only be achieved by the level of, again, by the interoperability. Timeliness, the results have to be shared as early as possible in the given timelines, so that it goes to the physicians for early management. Again, it needs interoperability, collaboration between various departments. For example, collaboration between emergency department, cardiology department, between OTs, surgeries. It can only happen with the flow between the various departments. And lastly, it was in cost, because as I mentioned earlier, it's a huge burden on healthcare nowadays. So efficiency, it would lead to streamlining the workflows through automated data exchange. Once you have your data getting exchanged between various departments, that would streamline the workflows. It would definitely reduce the manual data entries, which further reduces the errors and save time. And once you do have a flow, which is like automated data exchanges, it would lead to faster turnaround times for test results, which further improve patient care. Accuracy can be achieved by elimination of transcription errors and data inconsistencies. When you have a data flow from all the systems without human intervention, you achieve better accuracy. You have a seamless integration across ensures patient information consistency across systems, and reliable data contributes to better diagnosis and treatment decisions. Timeliness, as I said, any patient who comes to emergency, he needs his suspected case of heart attack or a myocardial infarction, where you have a split-second decisions to be made. It can be only happen when you have a real-time access to patient information file and the lab results. It enables rapid decision making and timely interventions, and of course, it enhances overall patient care and quality. But it can only be achieved with the help of a collaboration. This interoperability would foster communication among different healthcare institutions, entities, enabling seamless sharing of patient data and results, leading to better coordinated care. And by eliminating duplicate tests, extra tests would enhance efficiency, and interoperability would help reduce healthcare costs for both patients and healthcare providers. So why interoperability matters? It would matter definitely because it would lead to efficient data exchange. There is no flaw, there's no loss of any data between any levels. It would improve patient care by having a timely results, by having accurate results. It would enhance collaboration between various departments, and regulatory compliance can also achieve with the help of interoperability. So what is the importance of interoperability in healthcare? As I told you, it lead to better care coordination between different healthcare parties, between different healthcare institutions, higher performance, better treatment outcomes, HIPAA compliance, and patient data security for all the parties. It could lead to real-time electronic synchronization between healthcare providers and IT systems, facilitated through healthcare technology interoperability, custom-tuned collaboration between selected healthcare process actors, government institutions, government bodies, and other beneficiaries that provide their interoperable software systems, EMR workstations interconnected with the lab databases, insurance company applications connected again with the hospital databases, health plans, patient CMS, and all authorized operators can see data at the same time, would lead to real-time data sharing and exchange without any lags. It would lead to higher performance and better treatment outcomes, because now different physicians of different departments and clinical staff can access the latest version of medical records and see up-to-date information on patient condition without wasting their precious time. It would lead to reduction of risks in connection with medical error, elimination of unnecessary testings. Emergency responders can see every important lab details even before administering any urgent injections or drugs and make crucial decisions. Reduction of overall time required for working with electronic patient forms and records, thanks to autofill documents that can extract data from shared databases. Nurses and administrators can save time and effort on routine tasks. They need not fill every data, every sheet by their hand when you have your autofill documents. And even you can use rather virtual nursing applications can be integrated with other clinical software, including AI connected decision systems. So that is one important. Now, HIPAA compliance and patient data security is very, very important part of this. When we say there's a lot of data, obviously we have to keep this data safe and secure. So basically, you should have compatibility of our security standards across different healthcare application providers, making sure there are no leaks or no weak links between system components that could cause data leaks or other issues. Different vendors can develop mutually compatible applications, including medical softwares and devices that share the same standards and can exchange data without barriers. Physicians and patients can use different applications with the same authorization credentials and protocols to access and manage their records. What are the key components of interoperability? There are actually I would say 4 components to have a successful interoperability. You should have a system integration, data standardization, interfacing with healthcare providers, and privacy and security considerations. If you're able to achieve these 4 things, you can have a very, very good interoperability systems in place. Now, what are the challenges in achieving interoperability? Of course, when we're talking about so much data, so much integration, it can't be done without any. Should expect some challenges. And what are those challenges? You can have diverse systems and formats. Everybody is using different formats, different systems. Data security concerns are big issues. Technological limitations. One institution is at a higher level versus another institution, and resistance to change. So these are the four challenges which we need to overcome in achieving interoperability. So how can we achieve interoperability in healthcare systems? By actually having I would say five plans. Number one, you should understand interoperability conceptions in a very complete detailed manner at the stage of conceptual stage. Number two, review and prepare your healthcare data according to industry standards. Uh, we know Mr. Natarajan has shared us a list of standards. I also will have one small slide on that. But I think LOINC's standard for the lab, ICD 10, SNOMED CT, HL7, DICOM, FHIR are the common standards which actually helps this data exchange. Number three, identify the data to be exchanged. Number four, plan meaningful use of the data. And number five, deploy IT team to implement this change. Solutions and advances, cloud computing for centralized data access, IoT, that is Internet of Things, for real-time data transmission, and blockchain for enhanced security are good solutions in this area. For standardization and regulations, I have enumerated few standards. HL7, that is Health Level 7, is the most common standard used nowadays for all healthcare entities. DICOM, we know digital imaging and communication in healthcare for the radiology. HIPAA Act is important in US, whereas Health Insurance Portability and Accountability Act, and FHIR. I'll speak about FHIR and HL7 standard because these are the two important set of standards which are currently being used. FHIR is basically Fast Healthcare Interoperability Resources. It is pronounced as FHIR. It is a standard which has a set of rules and specifications for exchanging electronic healthcare data. It is designed to be flexible and adaptable so that it can be used in wide range of settings and with different healthcare information systems. The standard describes data formats and elements and an application programming interface for exchanging electronic health records. The standard was created by Health Level 7 organization, International Healthcare Organization, so it's called HL7. When we talk about interoperability, you always have to keep patient-centric approach. You always have to keep the patient in the center so that he can have access to comprehensive patient data. You can have a personalized care and treatment plan for the patient. Should have a benefit of informed decision making. Patient should have a faster access to accurate diagnosis. It would improve his treatment decisions and enhance the patient experience. So we have to keep our patient in the center while implementing interoperability in healthcare. This is just a picture which shows that how ultimately the patient, you can see all of these pictures, we have to keep our patient in the center and we ensure that all of the data comes to him by these devices. So for example, you have a web or a mobile app, then API platform connected with the health apps for patients, medical records for the hospital, devices like wearing devices, and lab results, or are interconnected through an API platform and are available on a web or mobile apps. So what are the 5 keys? So there are 5 keys basically to have a successful interoperability program. What is privacy and security? You should have enabled protected health PHI in a compliant manner. Strategy and governance. Roles with accountability for defining and achieving enterprise goals for interoperability. Program design. Program management to coordinate cross-functional delivery teams, decision makings, escalations. Operational readiness. You have to process and workflow changes to comply with the regulations. And technology and data integration, data ingestion, standard-based sharing capabilities, all should be in place to have a successful IP interoperability program. Future outlook, we can say that the rise of telemedicine and remote monitoring is one such outlook in this area. The evolution of healthcare landscape across the world, and the continuing importance of interoperability. So I would say I've seen 3 important areas where we can see how the world is going. AI integration. Interoperability can facilitate the integration of AI algorithms for more accurate and rapid diagnosis. Telemedicine enhancement. Enhancement of interoperability can enable better telemedicine experiences by allowing remote clinicians access to comprehensive patient data. Here, when I say this particular statement, which I like very much, because I wanted to see that day where the Medanta Medicity or Astra or any big hospital able to go to the same level of healthcare to our tier 2, tier 3 towns and villages. And just in the small kiosks there, the patient just enters there, and by wearing wearables, by all those devices, the physician in the central hospital can able to see his vital signs, vital data, and can diagnose him there. And finally, predictive analytics. By sharing data across systems, labs can contribute to predictive analytical models that can help identify disease trends and outbreaks. So basically, data analytics and insights are very important. It would leverage data for trends and patterns of any outbreaks. It would improve diagnostic accuracy, and it leads to enhance the patient outcomes. But you can only achieve, or you can only have this thing when you have recommendations. There are a few recommendations to healthcare providers. So basically, they have to do what they have to do is they have to support educational and for the clinical community in the use of data and standards. They have to specify adherence to open and recognize messaging and data standards in the procurement tenders, develop a testing environment, and ensure integration. In conclusion, I would say interoperability in diagnostic labs is a pivotal component of modern healthcare, streamlining processes, improving patient care, and fostering collaboration among healthcare professionals. While challenges do exist, ongoing efforts to standardize data, enhance security, and embrace technological advancement will continue to drive the evolution of interoperability in diagnostic labs, leading to more effective healthcare delivery. This is the picture I would like to say, by sharing data, saving lives. So this is that era we want to achieve with the help of interoperability. And finally, thanks for this patient listening and patient hearing. I hope I'm able to communicate my message on this topic. Sana?
Hello, hi. That was a really insightful talk. Like you
Yeah.
explain about the levels of interoperability and how it is important to incorporate it in the diagnostic lab. We do have a question for you. Amit wants to know, do you see any resistance in adopting the FHIR standard among healthcare provider community?
No, I don't think so. If you're able to give them this message that this would help the patient community, the healthcare community, they definitely would adopt, take this fire as a. I don't see any resistance there.
All right, all right. I hope, Amit, your question is answered. Rishi also says that your diagnostic lab's perspective complements the session.
Thank you.
Thank you. Thank you so much, Dr. Anuj. Please stay till the end.
Sure.
All right. All right. Hello. All right. We'll move on to our next speaker. It's we. Our next speaker is Ruben Viera. He's the founder and CTO of Rocket. He has over 18 years of experience in software development and technology, and he's joining us from Florida. So good morning to him, and he'll be talking about FHIR and interoperability in the U.S. market. Hi, Ruben.
Hello. So good evening good evening to everybody, and thank you for the invite. To say I've been a software developer for the last 22 years.
22 years,
Uh,
all right.
yeah, 22 years. 22 years in specifically in healthcare. So I've been working with healthcare for a while. So today I'm going to be talking to you about sharing with you my experience with FHIR, some of the things that we've seen since we've been implementing several projects on, and how is the interoperability right now, the status of the interoperability right now in the US market, and where are we going from now? And I'll be happy to share that with you when you're
All
ready.
right. Over to you. Thank
Okay. All right. So, um, as I mentioned, my name is Ruben Viera. I'm a software engineer, but also I'm a passionate about interoperability, and And I would like to share some of my. We've seen some of the definitions of interoperability today, and one of the main things that we need to understand is FHIR, or fast healthcare interoperability resources. Is a standard that it has multiple ways that it's going to make easy the sharing of information. So one of the main components of interoperability is a patient. So we all are patients. So in every single patient, in this definition of interoperability, I like because it's more humane and more that we all can relate, and it's going to help providers also to, as the previous panelists were talking and answering the question, if the providers are going to be show any resistance on FHIR and interoperability. I think they will not. And as long as everybody understands that we all are patients, we all have a story to tell. And the more complete that story is, the better the care that the healthcare professionals can give to us. So, as healthcare professionals, we all are responsible to tell that story, and that's what interoperability is. It's a way to share the story of that patient. So the next person that is gonna look at this patient or see or treat this patient is actually have all that they need and all the information to better care for this patient. So when we talk about interoperability, the first thing that it comes to my mind is not just standards, technology, or other things. It's more about a patient and how impactful is to have access to the right data at the right time. So to me, interoperability is that. It's the ability for us to share a story and to share a story complete, because that's very important. Um, we previously we talked about some of the drivers in interoperability in the U.S. market. The biggest driver for interoperability has been regulation, and regulation from government and from the industry. And we started on 2019 with what we call the federal interoperability efforts to actually promote and implement interoperability. So in 2018, there was a draft of the TEFCA, which is one of the government uh, entities that actually is promoting interoperability. And then so on, 2019, we start working with some of the rules that I'm going to show you in a minute. And it has been since every year we've been taking steps into the interoperability. In 2021, every single EHR in the United States had to have implemented FHIR. So today, all ONC certified EHRs are already utilizing FHIR. So and so on, we have been implementing some of the rules that we have at this moment. So in a minute, I'm going to show you where we are at and where are we going. So today, we have the CMS Rule 9115, which this rule basically required all the Medicare, Medicaid health plans to implement what it's a patient access rule. So basically, what this rule says is you have to allow third third parties or developers to uh, build applications and connect to the health plan data or to the patient's data in the health plan in a secure way, but using FHIR as the main uh, as the main framework or standard to 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 um, to transfer and to transmit data. So we've been working since with the patient access rule, final rule. We've been working personally for the last 3 4 years, and it has been a challenge, but also it has been very satisfactory too, to see how we have made so much advance in the implementation and giving access to other people to data. So today, this rule, what it says is the patient needs to have access to first their clinical information that the health plan already have, and to the financial information. So interoperability is not only clinical data, but also financial data and some other data that is relevant for that patient to care. So that's the rule that it was finalized in May 2020, and we've been interoperable at that level since then. But then there was some gaps and some other things that were needed for us to continue growing and promoting interoperability. So that rule allowed, that previous rule allowed us to share what was patient data access, but also has a provider directory, and also allow you to share some of the USCDI, which is another of the standards, and I'll mention it later when we talk about a little bit more about FHIR. So there's a new rule, and there was one of the parts of that rule in 2020 that require health plans to also send the data from the health plan uh, to the new health plan. Let's say that I am a patient, I got a new health insurance, I go to the new health insurance, all that information need to be shared with them. That rule wasn't too specific, and it created a lot of issues, and all the healthcare providers were there was no definition of what the standard was going to be used. So they proposed a new rule, and this rule is the 0057 rule. This rule, what it is telling, okay, if you're going to share the data from one health plan to the other, which is the payer-to-payer data exchange, so you need to share it using the same standards that you use in the implementation guideline for the patient data access, which is FHIR and USCDI, and some other of the standards, and we will talk about that. But not only they requiring everybody now in the health plan and the payer side to implement that part, which is the patient access, provider directory, and the payer to payer data exchange, but also now they are requiring the health plans to implement, or the health insurance to implement, a provider access API. So not only the patient will be able to connect to their healthcare data using a third-party developer application, but now the provider will be too. So this is great, because now if I go to the doctor, and I consent to share my data with my doctor not only is going to see the data that he has in his EHR, but he's also going to be able to see the rest of the information, the rest of the story, and that is great. That's definitely going to have a great impact, significant impact into what is the care of the patient, to improve the patient care, the patient care. So there's other standards that are coming with this rule. The payer-to-payer data exchange now is required. The FHIR is the standard. So that's why we're going to talk about a little bit more about FHIR in the end, because what is common in all these new rules is FHIR is the center of what interoperability is, the common language that everybody has to use. There's other processes, that the administrative process, that are very they don't work very well in here in the United States, and there's some examples are the pre-authorizations. The pre-authorization process is a process where if you have a very expensive study or procedure, you need to require to the health insurance, you need to request authorization to get that procedure done, and it is covered by the health plan, and that process is done by every single payer in a different way. So what this new rule is saying, we're gonna add interoperability to the pre-authorization process, so that we can also share that information. So there's also going to be some of this that is going to be improved now, and also um, implemented using FHIR and some of the implementation guidelines by the FHIR community. So the patient data access API, as I mentioned, patient data access API, now it requires that you share some of the clinical information and share with a third party and share that financial information with third party. So as I mentioned before, if I am a software developer, I can create an application and I can promote that application, and the patient can request to the health plan or to the health insurance to share his personal information, so the patient can have that information in their mobile app or in the portal or all that. So that basically allow me as a patient to have control and use the data when I need it, not when somebody else decide that my data has to be shared. No, I have control of my data. I share my data because it's my health, it's my data. So that's something that is very important. And when we talk about making the patient the center of interoperability, we also have to empower that patient to have access to their data so they can actually take control of their health. And that's why interoperability is important. It's not just a transaction of data from one point to the other, so one machine took to the other. Yes, that's the mechanical part of it. But what we do with the data is actually what it is important, and how do we use it, how we educate our patients to take control of their data. So say a patient monitor their diabetes or other healthcare conditions. That's what is really important. Is actually having and getting that access to the patient when the information is needed. At the same time with the provider. So the provider access API put the information of that patient right in the moment where that data is needed. So I've seen for the last 22 years a lot of applications and a lot of advance into what software development is in healthcare. But the truth is, we've been creating a lot of silos, and we're generating a lot of data, but that data is just scattered, and it doesn't help us. So by implementing what's the provider access API, definitely we're giving also the providers the information when they need it the most to treat that patient and to improve the patient um, outcomes. So now the payers, from the financial standpoint, the payers, the healthcare, definitely, even though we see it from this point, like it is just about the patient and to improve the patient care, but also has a financial impact. So it's an industry. So how do we make this industry more efficient in a way that health funds can also um, keep that cost low so they can provide better services. And one of the things that payer-to-payer API allow other health plans is to understand that population that is coming, that new population that is coming, how do I use the data? How do I analyze this data? So basically, it's definitely what payer-to-payer actually, that part of the rule that is going to help the payers also to receive that information and use that information in a meaningful way, to not only to evaluate that patient at the risk of that patient, but also to implement programs that improve the patient care, because the healthiest the patient, the more money I'm going to make, because it's not going to use the health insurance. So there is a preventive medicine aspect of this that we need to also understand, that if we prevent a patient, a patient with chronic kidney disease, we prevent this patient to get to a stage 6 of chronic kidney disease, we're saving a lot of money for treating this patient in other ways. So that's also what we look for into, well, that's why one of the drivers of interoperability too is not only patient outcomes, but improve patient outcomes, but also create sustainability of the healthcare system. So there's another aspect of this rule is what I mentioned before, is the improvement prioritization process. Right now it's a manual process. If you go to every single payer in the U.S., There's a lot of opportunities to improve their processes. Most of the processes require manual intervention, and they're isolated. And the information that me as a patient I have is minimal. So what uh, CMS and the regulators are actually trying with this rule is to improve this process. And again, one of the main drivers of interoperability is regulation. So that's why they say, okay, this process of prior authorization needs to be improved. Less than do implement FHIR and technology into it, so that we can actually make steps ahead in get this process in a good way. So Medicare is also saying, or CMS, a Center for Medicare Services, so it's also saying not only you're gonna implement a or mechanize or have a standard and implement FHIR in that prior authorization process, but also you're gonna report to everybody or to report to us how are you doing, what's your performance, and that's very important because for example, if you're a patient that require a CT or MRI or MRI of a high technology study, and you're waiting for 2 months to get a pre-authorization, will have a severe impact in your health. Let's say you wait 1 month or 1 week, still you're getting significant impact into and if you're waiting just for an administrative task, everybody should know, okay, this health plan is taking a month to approve this, or 2 hours, or 24 hours, or whatever. So that's why the Medicare is actually mechanizing or automating or bringing the standard and FHIR into what the rule is, because we also need to be able to measure performance of the health plans. So at the beginning, when we started implementing interoperability projects, and we built several major interoperability projects with different health plans. And one of the biggest problems that we have when we started in 2018, it was that there was no implementation guidelines, or the implementation guidelines were vague. So what CMS is doing with this new rule is that now we're actually saying, okay, these are the different implementation guidelines that we're recommending to you. So I recommend all of you that are interested in FHIR that also look at what the implementation guidelines are, because FHIR is a bunch of standards, and we will see them in a minute. But it's a bunch of definitions and profiles and that kind of stuff. But the what it tells you, what is a real life use case of FHIR, how do you use FHIR in a real life situation, is condensed into the implementation guidelines. So when you are actually going after this presentation and say you're interested in FHIR, look at FHIR as the model, but also look at as some real life scenarios, and you can find some of those real life scenarios in the implementation guidelines. So I'm not gonna go over all of them, but you have some of them in how they are applied to the different parts of the rules, like patient access API, provider access API, provider directory, payer to payer, and so on. Now, what are the proposed standards? And that this is what it leads us now to talk about a little bit more about FHIR. So every single part of the rule, it it's actually pointing, or it is being defined, that FHIR is the standard that we're going to use. The FHIR release 4 is what is proposing this new rule. FHIR already have 6 releases that are being worked. And if you go to the FHIR has HO7 has a standard page that is very good, and I also exhort you to take a look at it, because you're gonna see there's works already done in release 5 and 6. They're not mature enough to go to market, but we are currently now using FHIR release 4 in our production projects, and it's actually very stable, and it does have all that you need to implement that. That's why it's being promoted as the release that is actually will continue for the next, I think, year or so until the other FHIR release 6 reach out the maturity level. So apart from FHIR, we have other standards like USCDI, and USCDI is basically is a US core clinical data, and basically what that defines is if FHIR tells you how you're gonna format that data, in what format, JSON, XML, what data elements, what is required, what is not required, all that information, and how to transfer that data in a secure way, and what protocols you're going to use to send that data. That's what FHIR does. USCDI is actually telling me what data, like it tells me what are the data definitions, what is immunization, so what part of the immunizations I need to share. So I think USCDI tells what, and FHIR tells how. So that's basically how I see it. USCDI tells what data I need to collect, and and FHIR tell me how do I transfer it, how do I store it, how secure I put it. So you can take a look at this more in detail, but what is important is we know that FHIR is actually here. It's not something new. It's something that started a while ago. It's been in production uh, from 2006, 2016, 17, and probably more widespread in 2018 until today. So it's very it's used. So what is FHIR? So FHIR is a fast healthcare interoperability resources, as we have mentioned before. But why fast? Fast is because it's basically created in a way that allows us developers to build in a way. Why? Because it defines that JSON is going to be the format that we're going to send the data, and it's also telling us that we're going to use REST APIs to share the data. And it's telling us that we're going to use OAuth to manage authorization and OpenID and authorization with OAuth 2.0 and OpenID. So basically, if FHIR tells us that technical description of what we need to do to be able to develop fast applications, but also it defines a data model. So that's what it allows to actually, I don't have to worry how the database for EHR1 looks like versus EHR2, because they all now use FHIR, and the standard tells me that the patient name is always going to look like a patient name in all the other um, softwares. So basically, what are the basic concepts of FHIR? So FHIR have resources. Resources are, if you compare, or they're definitely JSON or XML documents. They're basically documents. But if you compare this to a relational database, a resource is a table. So you're going to have in a normal application, when a relational database, you will have a patient table. When you're building a patient application, you have the patient table. So now instead of having a table, you have a patient resource, and that resource have a definition of data elements and other information. So the beautiful thing about defining every single data element or data group or data collection in resource type, what that does is it allows us to then have a singular container that all the FHIR resources look alike. What it changes is what it is in actually there, but it's easy to transport. Like for example, I don't know if you're familiar with shipping containers in the maritime industry, where before you have to have a big ship to transfer products and service products and goods. Now you can have just similar ships that have shipping containers that are similar, so it facilitates the way of the logistics to transfer things from one place to the other. The same thing is FHIR resources. So basically, that FHIR resource is that shipping container that we're using to transfer the data from one place to the other. Then we have APIs, and basically what we're saying is that we're going to be one of the things that FHIR standard has is define that you're going to use API REST APIs in the way that you transfer data. So basically, you can access any resource or FHIR resource using a HTTP command, put, post, get. So that's what it makes it easy for you to develop because, as you know, we've been using HTTP and REST for a while now. So it's a common language for us, and that's why it also makes it fast for us to develop applications because we all know what a post or a get or a put. So we understand how to talk about. So now FHIR decide HL7 decided that now let's make this modern and that can grow and keep evolving. Let's implement RESTful as the way that we transfer data from one place to the other, and also say, okay, those resources that has the data, they're going to be formatted in JSON or XML. There's other formats too, but as one of the panelists also said before, JSON is what it has been implemented everywhere. I haven't seen an implementation of FHIR using XML so far, but I guess it will have its uses at some point. And then the data elements, what's required. There's some profiles and stuff that you're gonna see. So what are the advantages of FHIR? So flexibility. We can implement an application. We can create applications in very easy, but also the flexibility of the resources. I don't have to create, for example, before in a relational database or in a HL7 segment, there was some predefined fields that I need to have for my use case. In FHIR, I can define what is going to be in that particular resource. So it gives me flexibility to add and to create and extend those FHIR resources. Easy to use because we're used to, as developers, we're used to work with HTTP, with with JSON. We're used to create, so it's definitely create some easy to use, so making it more scalable, and also it definitely help us uh, to implement. So what is HL7? Because one of the important things is, okay, who maintain the FHIR, like who keep the FHIR alive. So that is HL7. HL7 is the entity, is the organization that is being responsible for developing not only FHIR but other standards in healthcare very successfully. It's a combination of different entities from the private sector to the public sector, and they are definitely the ones that are keeping those standards. I exhort you to go to HL7 website, and you're going to see their different standards, including FHIR. So they are the ones responsible for it. So if you need to know and you're curious to know how FHIR is actually implemented, go to the FHIR to HL7 websites, and you're going to find everything that you need in there. One of the things that also I want to mention you is that there's a lot of documentation for FHIR. There's a lot of things that you can actually starting to understand from the technical standpoint and from the clinical standpoint. If you're not a developer but you're a clinical person, I also tell you you should start looking at what FHIR is, at least understanding the basic concept. So when somebody say yell FHIR, you don't start running, and you know that it's a healthcare standard and not that something is burning. So everybody needs to understand what FHIR is and what how to use it. As a matter of fact, we the one we that use mobile phones, and everybody, I'm sure you do, you are actually have a FHIR implementation in your phone. If you're using Apple, all the healthcare information, all the health information and activity on your cell phone is basically structured in FHIR. So the best example that you have about interoperability, go to your health app in the Google Health, in Google, in Android, or in the iPhone. You're gonna see you already are using FHIR. That data that is stored there is already starting FHIR. As a matter of fact, Apple, in Google, in all the different markets, they're one of they're promoting, and they're one of the organizations that that are investing the most in FHIR, and making it easy to do. So um, there's some case studies like how do we implement the FHIR. We have implemented FHIR with electronic health records using population management. Population management is one of the use cases that it is more important. For example, in the case of COVID, you were able to define or to understand, and have and analyze the data from different places. Imagine if you have all that data in one format that everybody can use and understand. So that's very important. But also for us to analyze and um, data in a whole population setting, clinical decision supports, patient engagement, and clinical research. Those are all use cases that we're seeing in the patient engagement, from an appointment reminder to your patient portal to encourage that patient to follow guidelines and all that. That's very important. Clinical research, how we were empowering now researchers to, instead of having to use some files, and we can actually give them a repository of data where they can actually use it in a standard way, so they understand what the data models are. So that's very powerful. So I'll say thank you to you guys. I know there's a lot of information. I know that there's many people that talk about FHIR and all that. But I think, and the most important thing that I want you to understand, interoperability is much more than technology. Interoperability is the way that we tell that patient story, and we as healthcare professionals, as we are, because not we are developers, but we are actually helping the helping patients as well. So we are also healthcare professionals, and we have to see it as more than just technology. It is more. We are all patients, and what the main goal of interoperability is to be able to tell that patient story to whoever needs it and whoever is going to treat this patient later. So I thank you for your time. I hope you can, if you have any questions, just let me know. And I appreciate Gigians for the opportunity to talk to you today.
Thank you so much, Ruben. I don't think so. We have any questions over here. That was a really amazing talk on FHIR and the basic concepts of it. You also spoke about the peer-to-peer API and provider access API. Uh, Sometimes we don't really understand those things, but it is really good to know about these things. Thank you for your presentation, Ruben. Okay. Uh, we'll call upon our fourth speaker, Abhishek Anand. He's a tech lead here at Geeky Ants. Currently, he's focusing on health data and researching patient data in one place. His talk is about exploring FHIR and converting FHIR. Hi, Abhishek.
Hey, hi Shana. So,
How?
can you start now?
Yes, sure. You can
Okay,
begin.
sure.
Over to you.
So, um, Mr. Ravi has talked about so much about the interoperability. Ruben has also talked about interoperability and FHIR. So, I'm going to talk about the data exchange using the export FHIR and convert FHIR. Okay, so I'll also start with some interoperability stuff. So it's it is just like data is at one place. I see the what interoperability means is like, let's say Mr. Ravi has talked about they are transferring the Aster one hospital and Aster second hospital, and there is in between there is an interoperability system is sitting and talking with these two hospitals, right? So just imagine it's not Aster. Let's connect with multiple hospitals, like Aster is communicating to Apollo, Apollo is communicating to Fortis, right? So let's say there has been some serious patient we are having in, let's say, in Apollo, and doctor is treating, and doctor is saying, no, we need some other doctors, those who are sitting in the Fortis, and they can communicate. But how they will communicate right now? They will communicate using the phone, like this is happening in the patient, and that is happening like this only, they can communicate right now, right? But if just think about the interoperability system, if it is there between these two hospitals, then communication is like it is way more easier, right, to between the doctors, and we can save so many lives into that. So that's what I see, the interoperability makes an impact in the healthcare market and healthcare industries. Okay, so and again, it's same goes for insurance companies, like payers to payers communication, payers to patient communication. And this communication is it is way more easier when we will have the interoperability system. Now, how we will implement the interoperability system between two hospitals, between two entities, between two payers? We should have some standards, right? So that is where comes FHIR and HL7, right? So if we are having some standards, then we can achieve this easily, uh, um, using some secure channel, correct? Okay, so I'll go to next slide. It will talk about the peer-to-peer data exchange. It's what it does. Like actually I see it reduces the burden of the administrative uh, people, and it is sharing data between each other, like payers to payer, payers to patient, payers to hospitals, hospitals to payers. It is also empowering the patient, and it is also enabling the coordination of care and patient care people and the patient, correct? I'll just give the one real-time use case. It can happen with anyone. Like, let's say someone's father and mother is in their hometown, and his son is staying in Bangalore or somewhere else, and he is having some heart attack or something in the village. And then doctors, maybe some doctors had seen in the in his village, right? So the doctors cannot communicate when it will come to the big hospitals there, like what medications that doctors has given there only. Interoperability makes an impact over there. Okay, he is coming from the Patna Apollo hospitals, and he's coming to the Bangalore Narayana healthcare. So their interoperability system will makes an impact that, okay, this particular patient is this particular patient had this particular medications and this particular procedures, and now they have come to the Narayana health, so they will come and see it, like what is happening with him, okay? So that's what I keep telling. Interoperability system is making an impact, right? So this is about the real-time scenario, real-time use case we are having between the patient and the multiple entities. Okay, so let's go to the what problem we are having in the current healthcare industry. So our data is very much fragmented between the multiple entities, like let's say in the hospital, in the hospitals, in the insurance companies, and in the pharmacy, in the diagnostic labs, all where your data is there. But when doctor wants to see it, then you have to take a pen and paper, and sorry, not pen, paper, and take you to the doctor, and then they will see it, right? So if interoperability will be there, then they can see anytime, right? So these things. So, and again, it is hindering the optimal care, right? So if data is fragmented, then obviously it is care will be little less how we want to, correct? So again, it is same data is filed within the separate stakeholder system. What it means is like your data is with one insurance company, and then if you are moving to the another insurance company, then previous insurance company data they cannot see. They have to go with again and again each and every procedure, like again you are going with the health checkup and all everything, right? So if data will be enabled to see to everyone over the consent, then it is very easy to move from one entity to another entity, right? So and and if you are maintaining your data in multiple entities like hospitals, insurance, or everywhere, then it is very expensive to maintain that server also, right? So so that's what we are having there. We can do the data exchange using the interoperability and export FHIR. So I'll talk technically also. We have enough we had enough talk about the theoretically, like what is FHIR, and I'll show that how the lab data looks like, how the patient data looks like. I'll show everything here. Okay, so what we need to do that, what payers has to do that. So they will receive the member data, then they will produce new health plan, then again send the member data. I'll come to this part in details later, but before that we'll go to the next slide. Okay, so if you can see that what we have to do technically, we have to create the health data service workspace in Azure portal, and then you can deploy your FHIR service, and you can configure your import. Okay, and you are good to go with your data exchange. Definitely, if we will have the definitely we need to do these things in the very secure channel, because data is very much private to the patient, right? So let's go and create the health data service workspace in Azure portal. Okay, so I hope you all are able to see my Azure portal over here. So you can see here, this is my Azure portal, and you can search here health data service workspace, and you can go to the workspace and you just click on create. I have already created a workspace for the POCs, but I'll show that. You select your subscriptions over here, then you select your resource group. If you want to create new resource group, then you can create it, but I'll just use this one. Then workspace name, you can give anything, any useful name, whatever you want. Let's say I'm saying geeky demo FHIR py. Okay, so it will check if it is available or not. You can select your reason, and then you just do the review plus create. Okay, and that's it. You just create it. Okay, and that's it. It is done. The healthcare workspace is done now. Okay, so I'll show the how it looks like healthcare workspace. Let's go to the whatever I've created for the demo. So it's a geeky FHIR health data service workspace. You can see here we are having here 3 services which I have talked about. The FHIR service, right? So if you're clicking over here, then you will have an option for to create the FHIR service. It is also very easy to create it. Just click on plus icon, and you can give the some useful name, like I'm giving geeky demo FHIR service, and it please select your FHIR version. Like currently we are having available STU3 and R4. You can select R4 and just do the review plus create. Okay, and just create it, and it will create your FHIR resources without, I think it will take 1 or 2 minutes. That's it. So that is why I've created all the thing in place. So it will I will not waste time over here. So you can see here in FHIR service we are having a geeky healthcare. You can click on geeky healthcare. This is your FHIR service. This is where, and this is your FHIR server. This is where you are saving the data, and this is why where you do so many things. Like if you having data in one place, then you can enable the AI, you can enable the data analysis and all, right? So you can do anything. You can do the reporting in the CRMs. You can do you can share data to the Synapse. You can share data to the AI platforms. Correct. So this is your URL now. Okay, so you can just hit this URL and you will see your metadata over here. And if you are seeing this metadata, then you are up with the FHIR server. That's cool, right? So let's go to the FHIR server, and then what you need to do, you need to configure export but before going to configure export, I just want to show the how labs data looks like, how patient data looks like in the FHIR in HL7 format. That I'll show in the Postman. I hope my Postman is up. Yes. So I have created some secure channel over here. So I'll just create some latest token. So this is the token we are having, and I'm written some internal scripts to the Postman to refer all the token information to all these APIs. Okay, so let's see the patients, like how the patient look like. Okay, so see, I've referred the geeky auth token. So let's say I will show how the patient data looks like. So this is what is the type of resource type I'm using. This is the patient resource type, and this is the our identifier sections. How we are saving it name, let's say Abhishek, Anand. I'm saving with the Peter James, and the family name is Chalmers. And then there is the telecom section, like home phone, and then the gender, then birth date, and then there is the address. Okay, and this is the contact and contacts address, and then what organization it is. This is what the entity I'm talking about. Like this entity is from any organization it can be, right? So this is dummy ID, which is 1. Okay, so let's create the patient over here, and I'll use the post operations. Just send it. It'll take some time. Okay, it's good. It has been created. Cool. So the data has been created over here. So I'll just go through with the multiple multiple um, API nodes. Okay, so sure. So I'm going to create one organization right now. So this is the data we have captured from the HL7 website, and I'm going to create the organization over here. So let's do that. Okay. So if you want to see the URL where I've kept it, it is saved in the environment globals. So this is the URL. This is the FHIR service we have created, and we are creating the data to the FHIR server. Correct. So let's create some. I'll show something interesting now. It's the hemoglobin data in the FHIR. Okay. So I'll just take some time. No. Okay, you can see it. We have created one organization, and there I'm creating one observation. So this is the hemoglobin example, guys. So you can see here which patient I'm going to create. This name is Amy Shaw, and what is the value quantity they have got? They have got is 17.0 G/DL. And what is the references? You must have seen in your biochemistry analyzer report, right? So this is the range 16.5 to 21.5. Correct. So this is where, see here how the FHIR saves your reference range and your value quantity over there, right? So you can see this is your value, and this is the reference range we are having, right? So, and what it says, it is the normal range. Okay. I'll just create it, and here you go. You have created one observation data which explains about the hemoglobin values in your body, correct? So this is how we can create the multiple nodes we are having. You can see, I'll show something interesting again. 1 minute. See, we are having data for sample data for all the nodes, like patient, practitioner, care team, device, organization, location, clinical data, diagnostic data, medications data, workflow, what we if we want to create some workflow, and then financial, like claims, account, invoice, charge item. So this is what we are having. And already I have shown that how easy to create the patient data, how easy to create the observation data in right. So now I'll do the export part. Okay, fine. So now I am for doing the export, just click on configure export, and you select your storage account, and that's it. You are good to go for the export also, right? So for export also, we need to call one API, and it will say you that your export operation has been accepted, and after some time your export operation will be completed also, or if it is in progress, then it will come in the headers. Let me show you in the very clean way. Okay, so export, here we are having an export, and you can see um, I'm just calling it. See, it has been accepted, and you can check your status using this particular URL. In body you will not get anything, you will just get 2202 accepted, and in headers you will get the content location. Where is the content location? I must show you in the Azure portal also, like where it is coming. Okay, so let me show you there. Okay, so it is something, sorry, this is the blob we are having. You can go to the containers, and you can see the export 21773, right? And I have already exported this export 1 and export 3. Let's see what it comes over here. You can see export 21773, correct? So this is what we are having the data about the patient, what all the details we are having in this particular system for that particular patient. We all will have that data. Okay, so let's see here what is inside. See here how many datas, how many files they have created in the container. Okay, so this many data we are having there. Okay, so just you can see here how the data looks like. Okay, you can see this all data, and just imagine it is getting shared between pairs to pairs, and they can the patient can avail the better facilities between with another pair, or if there is good facility in pair one, then there is no problem, right? So if a patient wants to avail the another pair facility, then it is very easy to avail that, right? If it is data is being shared between one pair to another pair, right? Let's say this data some doctors needs, then it is very easy to share it between the hospitals to hospitals, hospitals to labs, labs to pharmacy. It is very much easy to share the data, right? So this is what all about, guys, the export operations in the FHIR. Now I will talk about the convert FHIR. Okay, so I might go to the next slide. So this is already I have talked about what is peer-to-peer data exchange API. This is nothing but the export. So again, if you are having the seamlessly data exchange between two systems, then you are having better member experience. It will reduce your cost. There will be a good transparency between payers and patient, payers to payers, and payers to labs, payers to any hospitals, correct? So this is what interoperability does for us, correct? Now, so the second is the convert data. Now we are having multiple source of data. Let's say we are getting data from labs, we are getting data from insurance, then we are getting for data from hospitals, pharmacy. Then we are having multiple formats of data. But in US we have recognized three types of data, which is JSON, CCDA, and CCDA and HL7, right? In nothing but it is ADTs. Okay, so let's go to that particular API and see it, like how it looks like. Okay, so for convert API is also it is very easy to do that over here. Let's say um, Mr. Ravi has shown some ADT sample, right? This is what the ADT looks like, right? So what is the patient PID? This is the patient information, right? This is the name of the patient. This is the MRN ID of the patient. So this is what, like, you have to read the data in terms of technical if you are doing that. So and convert it. So how it is getting converted? It actually in between there is some liquid engine who does for us this one. So I'll show where what is the template I'm using over here. I can say, you can see here the template. This is the default template what Microsoft FHIR provides us to convert it. Okay, so Microsoft Health / FHIR convert :default. Okay, and the root template I'm using ADT01. Okay, so this is what we are having the input data. This particular data will get converted to the this FHIR. So let's send it. It may take time. Oh, it is done. So it is actually converting data in the bundle format. You can see all the whatever data it is there, it will create in the multiple resources of the FHIR APIs. Okay, so you can say this is the provenance data, and this is the organization data. Again, organization, this is the patient details. You can see here I already said, like, what is this particular data? This is the MRN data, right? So you can see here, this is the MRN data, right? So it is happening like that, guys. See, this is the name, sorry, not name, this is the name, Joanna Chelsea. Okay, so this is what we are having over here, right? So this is what about the convert data, guys. So if you want to see in your local, like how data is getting converted, and how I want to see the like locally, that how data is getting converted and how liquid engine looks like, how CCDA looks like. So I'm going to show this right away. Okay. So see, this is the there is a very simple 4 or 5 steps you need to do for creating the FHIR conversion from the ADT from the CCD. Okay, so first of all, we need to create one Azure container registry in your portal, and you need to log in over here. So I hope I'll just show how to create it. So you are having the container registry, just click on create, and you just give your resource group name, in registry name, you give your reasons, and what SKU you want. You can select it, right? So you just click on review plus create. It will validate your details, and it will just create your Azure container registry, correct? So whenever it is it is creating, after finishing of the container registry, we need to log into the in Visual Studio Code. Okay, so let's go to the Visual Studio Code. So how to log in? First of all, you need to install the FHIR connector over here. So FHIR connector extensions, you can um, FHIR converter over here, and this is the um, FHIR converter we are having over here, and you have to install this, and then you have to uh, you have to you have to just use this particular fire converter extensions. um, just fire converter login to Azure Container Registry, and you need to just give your Azure Container Registry URL. So where you will get the URL, it will be available in the your container registry. So this is what I have created. This is what you have to use over there. Okay, so um, just a minute. And here you have to do and press enter. Since I have logged in already, so it will easily I can show it under steps of it. Okay, so we are having the in the uh, command called pull sample templates, pull sample data, and then create a workspace. So when you do that pull sample templates, it will ask you for the what type of data you need. So data is needed as CCDA, HL7 version 2, or JSON. So these are the three types of data we are having over here. Okay, so so this is what you have to use. Let's say you are selecting the CCDA, then it will ask what template version do you need. So it is needed a version 5.1. Okay, so so I'm selecting version 5.1. Then it will ask for the um, uh, any root, whatever the output folder you want to download, it will download there. So let me show you that how it looks like. I have downloaded already. Okay, so this is our Fireworks space where we have downloaded the HL7 datas, and where we have downloaded the templates, which is this templates, and the template HL7 and template JSON. Okay, so this is what we are having over here, and I have downloaded the sample data, which is CCDA data it is, and the ADT data it is, and the JSON data it is. Okay, so this is what you will have it, and then when you will create the converter workspace, then it is going to create it like this. You will give the name geeky demo dot fire converter. I have created one for CCD and one for ADTs. Okay, so it is like that. So I'll just um, then then the UI will look like in the Visual Studio Code. You are having all the liquid engines, you are having all the CCDS file, and 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 things, right? So let's select this CCD liquid. I'm selecting for the fire converter select test template. So I'm selecting CCD dot liquid as a liquid engine, and I'm selecting uh, uh, this particular amb underscore cc data as a data. Okay, and then I will just convert it. Okay, fire convert. So it will just convert that your fire. Okay, so this is the fire JSON we are having, and this is the liquid engine looks like what all the sections you are going to use, whatever we have written over here, ccd dot liquid. The section pair you need, section nutrition you need, mental status, medical equipment, these all are the sections of the resources. Okay, so these all the resources will get converted. If we will not write it, then it will not get converted. Correct. So this is our hurt, this is our analyzer, like how it analyzes our CCD data or ADT data. So it depends on this liquid engine how it converts. Okay, so this is all about the data, like how we are converting the data over here. And then I already explained about the how it does. Like this is the input, and in between, sorry, in between liquid engine comes, and then it converts to the output data. Okay, so This is it from my side. So, over to Sana. I think.
Hi, Abhishek. Your camera and your mic setting changed a little bit.
Oh,
So if you can fix that.
okay. Just I think my camera battery has been exhausted. That is why. Okay, no
All
problem.
right, all right. All right. It was a really great presentation, and you spoke about so many things, and it was very informative, technical. We do have a question for you. Is Azure Fire Service expose the endpoints for all the resources?
Yes, yes, yes.
All right. All right. There is nothing, but we have got a lot of compliments for your presentation, Abhishek. Thank you so much for joining in and giving us such an insightful talk. We'll move on to our last speaker for the day, Kapil Rijhwani. He's a software developer at Adobe. He has worked with Microsoft and ServiceNow as well. He also likes to network with like minded people to discuss tech and startups. Today, he is here with us and he's going to talk about the 10 benefits of artificial intelligence in healthcare. Hi, Kapil.
Hi Sana, how are you?
I'm good. I'm good. How are you?
I'm doing great, thank you.
All right. You can quickly jump into your presentation. All right. Over to you. All the best.
Thank you. Yeah, can you confirm if you are able to see my screen?
Yes, we can
Okay,
see your screen.
okay, let's get started. First of all, thanks to Geeky Ant for helping me present over this platform. Today, here we are going to delve into a subject that bridges the cutting edge technology with the human well being. In short, about 10 benefits of artificial intelligence. So, let's get started. The first benefit is enhancing the medical diagnostics. AI has a progress in analyzing the complex medical data like the radiological images, which can help us in groundbreaking outcomes. This can help us in getting the faster and precise diagnostics, which can help us in early disease detection and better outcome. For example, Google's DeepMind AI has boasts an accuracy of 94% in detecting the signs of diabetic retinopathy by doing the retinal scans, which is far better than any of the human performances being seen in the past. Moving ahead, it can help us in personalized treatment plans. For example, artificial intelligence can help us ingest medical records, research, and clinical expertise to suggest various treatment options based on person's history. This data-driven approach can handle a new era of precision medicine. For example, we can have tailored plans which will help us in better responses and reduce side effects. The real life example of this being IBM's Watson suggests customized therapies for cancer patients based on their individual history, based on their particular records, and what are the things they are allergic to. This can help us in preparing a better plan. Moving ahead, drug discovery and development. Like like being discussed in previous points as well, with the AI, we can try to ingest all the data which is there, the medical history which are there, which can help us in introducing new drugs development. For example, we are seeing a new outage of any virus which in there in the new geography or something. Using the medical data for that particular geography or particular region, AI can predict what can be the protein structure for the drugs which can help as an antidote for this. So this can help us like identify the drug target for a rare disease, which can help us the targeted patients get a ray of hope. Moving ahead, the predictive analytics for patient care. So I would like to relate this example to the COVID-19. Like using all the data sources which we have, for example, getting the data from the news, getting the data from social media, and all the travel data set which is available. It can identify the patterns in the global travel and try to predict. For example, the Blue Dots AI platform had predicted the outbreak of COVID-19, and this happened even before the official alerts came into picture. So these kinds of alerts can help us in real-time monitoring, early intervention, and better be prepared for any kind of pandemics or virus outbreaks in the near future. Moving ahead, the administrative efficiency. So, with the help of AI, what we can do is we can try to help the medical staff focus solely on the patient side, whereas AI can handle all the admin tasks, for example, scheduling, billing, and all the manual things which can be done. The example of this is the Cleveland Clinic's appointment bot uses the AI chatbots for making the appointments based on doctor's availability based on the particular day, and it also provides a FAQ list using which the patient can take it immediate steps in case he is not able to reach out to the doctor. Moving ahead, the virtual health assistants. So let me give you an example. For example, the doctor has prescribed the medication to the patients at particular amount of time. Then they had suggested the particular walk activity or some kind of a aerobic activity, but the patient is not able to adhere to those standards. AI can come into picture and help us. For example, the AI powered assistants can provide reminders, advice, which can help us in better patient engagement and adherence to medicines. There has been voice assistants in the market which can help us with the medication reminders in such case. Moving ahead, radiology automation. So why radiology automation? As we have discussed in the earlier points also, but in radiology, we have seen the cases wherein artificial intelligence has predicted using in the medical scans the early symptoms of brain hemorrhage, which can help the patients get treatment better. Also, this can help us in finding new trends, new patterns in the new outbreaks which are happening in the particular domain. Moving ahead, the ethical considerations. So, as all of you are aware, once the topic of artificial intelligence comes into picture, everyone is concerned about the ethics which are being followed or not. It can be related to privacy of data, whether their data is private to them or it is getting leaked, whether it's biased or not. So, there has been initiatives. For example, Stanford has created an initiative for fairness in AI, which will reinforce that any treatment which is being given to the patients is being in unbiased form. All the algorithms are fair and they are unbiased irrespective of the patient's history, and the patient data remains secure within the boundaries of the organization. Moving ahead, the remote patient monitoring. As being presented in the earlier talks, that the example of the Apple Watch, which can help us in getting the patient's heart data and help doctor with all these data. So therein, there are specialized companies like Bioformis, which has developed an AI powered wearable device that can help us monitor the patients in real time. So, to give you an example, in case there are patients who are having a history of a heart failure and they are wearing this device, in case of any anomalies, any outbreaks in the pattern, or anything, any unusual activity, an alert can be sent to the nearest doctor, nearest hospital facility, and this can aid us in remote patient monitoring because the doctor cannot be available at convenience for all of us. This remote patient monitoring can be considered as a boon with the help of artificial intelligence. Moving ahead, the medical research acceleration. So AI can help us in identifying what can be the particular antidote to a virus coming in, or there can be a complex spread which is happening across the globe. In that case, using all the data which we have, it can help us in identifying what can be the top three or top four drugs which can help us prevent the disease and take particular actions. This cannot be done without the intervention of artificial intelligence, since it requires a lot of complex analysis and trying to go through millions of records of data in the history. So yeah, this was all I had from my end. I had kept the presentation short to keep it engaging. In conclusion, we can say the AI's penetration into the healthcare fabric is seismic. I hope you were able to learn few points out of this. My heartfelt appreciation for all your presence. And yeah, in case you want to reach me out, I will available on LinkedIn. Yeah. Thank you. Over to you, Sana.
Thank you so much, Kapil. It was really short and crisp, and you spoke about how AI can benefit in surgery, medical imaging, diagnosis, and treatment, among all the other things. Thank you so much. Uh, I think we have Ravi over here. We can call him up on stage. We can have a quick group photo. Hi, Kapil. Hi, Ravi. Hi, Kapil. Uh, cannot hear you, Ravi.
Hi, Ravi. Are you audible?
Ravi,
Just
can
one.
you?
Yeah. Can you
Yeah.
hear me now?
Yes,
Okay.
we
That's
can
hi,
hear.
Kapil.
Hi, Ravi.
Uh,
That was
we
yeah. That was good. Yeah. Very
we
nice.
have Abhishek as well. I don't think so his camera is working, but come on in, Abhishek. Hi, Abhishek. That was really great presentations and great talks. Very informative session. I'm pretty sure our audience also liked it. I
Very nice.
I, I do know that we kind of went 30 minutes above our beyond our time limit, but I think it was great.
Ruben has left already.
Yes, Ruben has left already.
Can you guys see me?
Yes. Hi, Pramada.
Yes.
Hi, Abhishek and Pramada.
Yeah.
I think we'll just take a quick group photo.
Yeah.
Great. Thank you so much. Thank you everybody for joining in. And thank you Ravi, Kapil, Abhishek, Pramada, Ruben, and Dr. Anuj. I'm pretty sure they're watching online. Uh, let's we can wrap it up for today then. Thank you everybody. Pramada, do
Thank
you have
you.
any
Thank you very
thoughts?
much.
No, I think everybody, thank you so much. It was quite insightful. And we are going to have another round of meetups, probably for Q&A, because I saw there were a lot of questions flowing and we could not answer those questions. So probably be ready for the next Q&A sessions. We can have more virtual meetups to have people joining in from different parts of the world. Thank you, everybody. Have a good day. Good evening.
Thank you. Thank you.
Thank you. Good
Bye.
Thank
evening.
you.
Bye bye.
Bye.